I am Anil Kumar. Welcome to my series on sketching graph of composite functions and writing their domain and range. Take it as an exam practice. This video is also very helpful for students who will be taking calculus. So it could be a part of pre-calculus. We'll sketch graph of five functions in this particular case. We'll begin with the absolute function x minus 1 and then do composite functions with the absolute function. First, we'll divide the absolute function by a linear function, x minus 1. Let's call them as f of x. Now, with f of x, we'll have three more composite functions, one with the cubic function, then square root function, and this one is a semicircle. So these are the five functions which we are going to work with, and we are going to sketch each graph, write its domain and range. Let's begin with the very first one, which is sketching the graph of absolute function. Now, there are many ways in which you could sketch graph of absolute function. Let's figure out how could we do it. So, depending on what you have learned so far, what the best way, rather the simplest way could be that we could make a table of values, right? So we could make a table of values, providing some giving x values, and then we'll find out what is the absolute x minus 1 value. Now, such values, you should begin by getting a result of 0, which is for x equals to 1. So if I substitute 1 here, in that case, we get 1 minus 1, which is equal to 0, the absolute value, correct? Now, as soon as you sketch with 2, for x, 2 minus 1 will give you 1. The value of 3 will give us 3 minus 1 as equal to 2. If I substitute 0, we get 0 minus 1. The absolute value will be minus 1 absolute, which will be 1. And for minus 1, we'll get absolute value of minus 1, which is 2, right? So minus 2 absolute value is 2. You can definitely plot these points and sketch your graph. Perfect. You could do that. So let me now sketch the graph with the help of these points. So let's draw the axis first. So let's have the axis with, let us say, let me sketch it here as the x-axis and the y-axis. Let us take it right there in the center. Now clearly the points are beginning with the one here. So at 1 we get a value of 0. So that is the 1. And then the absolute function goes like a straight line, as you can see, on either side, right? But the values are positive. So this is what we get as the graph of this particular function, right? So this is one way of doing it. The other way, let's call this as table of values. Now, some of you could have also sketched with the help of transformations, right? So let me write down here, transformations. Okay, so you know the function f of x equals to absolute value of x, and then absolute value of x minus 1 will be 1 unit, right? Correct? So absolute x would have been the function kind of like this. That was the value for absolute x. And then when you translate this by 1 unit to the right, all the points, what you get is the function, which is, we are calling this as a value, a of x. Is that clear to you? So that is how you will actually sketch. So these are very popular methods to sketch the graph. And of course, you should be labeling your graph. Now, the other part is to write domain and range. So clearly the domain is all real numbers, no restrictions at all. So we can write x belongs to real numbers. As far as the range is concerned, range is y belongs to real numbers, but y values are greater than equal to 0. They're always positive, and that is typical about the absolute function. So with that, we get the graph of ax, which is absolute value of x minus 1. Now let's take the graph of the next function, which is f of x, and it is written as absolute value of x minus 1 divided by x minus 1. Now how should we sketch this particular graph? Now one way is that we could write the absolute function as a piecewise function, correct? So in that case, we could actually write this as absolute value of x minus 1. Uh, this will be positive if x is greater than equal to 0, right? So you could notice from here that this half where we have the x value which is greater than equal to 0, it is same as the positive value. On this side, the graph which could have been like this has been reflected, correct? So this is the portion for x less than 0. It has been reflected. So taking that into consideration, I could write the numerator as x minus 1 for x greater than equal to 1, right? Add 1, it is 0, correct? Divided by the linear function, which is x minus 1 in this particular case. If the value of x is less than 1, in that case, it becomes negative of x minus 1. So I could write negative of x minus 1 over x minus 1. So clearly, we could rewrite the function f of x as equal to either plus 1 or minus 1, depending on the x value. If it is greater than equal to 1, it is plus 1. But if x value is less than 1, it is negative 1. Now that makes it simple to sketch the graph. So let's just sketch the graph, drawing the x-axis and the y-axis. And then we have the value. Now what happens at x equals to 1? Strictly speaking, we cannot have x as equal to 1. So there is a restriction that x is not equal to 1. You have to keep that in mind. So definitely, if that is the restriction, you could not have written x greater than equal to 1 in this particular case. We should have written x greater than 1, correct? So these two values are for x greater than 1 and x less than 1. So clearly the function has a restriction. Since the denominator cannot be 0, we should write x is not equal to 1. Now what happens at 1 then? Well, we have, in this particular case, these values cancel, right? So when you get plus 1 and minus 1, then in that particular case, since the factors are cancelling, we have a whole at x equals to 1. Clearly, right? Now, so when you sketch this particular graph, you have to keep this thing in mind. So on the right side, it is begins with the whole, but now moves for x equals to 1. On the left side, it again begins with the whole, at x equals to 1 and goes towards the left side. The value is minus 1. So the graph will be like this. So this is at 1, this is minus 1, this is plus 1. So the graph of this particular function will be two straight lines, horizontal lines, kind of a step function, not exactly, but still. So it is kind of a step function with a discontinuity at x equals to 1. Now, for this we could write domain as what? So domain here is x belongs to real numbers. However, x is not equal to 1. As far as the range is concerned, what is the range of this particular function? Well, the range of the function is either the value is 1 or it is minus 1. So one of these two values, correct? So that becomes domain and range of the function given to us, f of x. Clear? Now let's take the next example, which is we're combining the function f of x as equal to, let's write down f of x here, since that page was defined as equal to 1 or minus 1, 1 for the value when x is greater than 1 and minus 1 when x is less than 1. So definitely f of x is not defined for x equals to 1. So we can write here that x is not equal to 1. That is a restriction. Now we need to sketch the particular function g of x. Now g of x is product of f of x and x cubed. So that could be written as x cubed for x greater than 1 or minus of x cubed for x less than 1. So that is the graph which we are now interested in. Perfect. Since g of x is the product of f of x and g of x, where f of x is defined like this. How should we sketch this particular graph? Let's again begin with the x and y axis, placing the x-axis and the y-axis almost at the center. Cubic function, is an odd function, symmetric about the origin itself. Now, I will kind of sketch the two functions here. So let me begin with sketching the function f of x. F of x, we sketched something like this, right? So that was the function f of x. Right, so this is, I'm writing as f of x. Now, let me also sketch the function x cube. X cube, if you place the values, or 1 cube is 1 and 2 cube is 8. So at 2 it would be 1, 2, 3, 4, 5, 6, something very high. We can say kind of like this. Is it okay? So at 1 it is going through 1, minus 1 I mean, and then it's kind of like this. So something like this will be your x cube function. So let me write this as x cube. Now, product of these two. Definitely we have a hole at x equals to 1, so we'll still have a hole at x equals to 1. That is for sure. The part of the graph which is on the right side of x equals to 1, that is x equals to greater than 1, will be exactly same as it was earlier. So we will just make it bolder to indicate that this will be exactly same as it was earlier, since all the values are only multiplied by 1. Correct? The other half, which is on this side, will get reflected. Now, since it becomes negative, right? So you observe that this becomes negative. So that negative reflects on x-axis. So reflecting this part on the x-axis will be kind of like this. Okay? With a hole definitely at this particular point. And the other half, which is the lower half of this, will actually go from, instead of minus 1, we get the value of plus 1, and at minus 8, we are going to get plus 8. So this portion of the graph will be kind of like this. So that becomes the graph for the given function g of x. Is that correct? So that is how we are going to graph it. Now let's write down the domain range of this particular function. So we are saying domain of g of x is what? So clearly it is all real numbers except for 1. So x belongs to real numbers, but x is not equal to 1. Since the function f of x is not defined for x equals to 1. Now the range, you can see from the graph the range of the function, otherwise it was slightly more difficult. So you can clearly see from this portion that it goes from minus 1 and above. So you can say it is y belongs to real numbers where the value of y is greater than minus 1. And that is how you get the domain and range of this particular function. So I hope that is absolutely clear. So split the graph into two. So it is kind of a piecewise functions, right? So let me write down here, piecewise function. Whenever you're graphing with composition of absolute function, it kind of splits the graph into two pieces. And then you get a piecewise function as shown, and as we are working with. Now let's take the next example, which is square root of x plus 1. Now again, we'll begin with uh, dividing the coordinate plane by x and y axis, sketching against a composition. So we are talking about h of x, which is absolute value of x. F of x, you remember, is the, let me write down f of x once again here, which was equal to plus 1 or minus 1, plus 1 for x greater than 1 and minus 1 for x less than 1, correct? So h of x will now be defined as square root of x plus 1 for x greater than 1, and for the value when x is less than 1, it is what? Now, before we write down this, we should work on the domain and range of the function itself. We know for f of x, it is not defined for x equals to 1. Now, in this particular case, we know that x should be greater than minus 1, otherwise, we get something which is negative within the square root. So, x plus 1 should always be a non-negative number. Now, we also know that x is not equal to 1. So, these are the restrictions. So, that means when x is greater than 1, that's fine. But when x is less than 1, so we have a lower limit of minus 1 for us. It could be equal to minus 1, and it has to be less than 1. So, within this interval, we have a negative value of square root of x plus 1. Correct? Okay. So let's first sketch both the graphs. One for the absolute function, which we had been doing, divided by the linear function, which is the graph of f of x. And now let us sketch the graph of the square root function, square root of x plus 1. So now I'll sketch the graph of square root of x plus 1 in green. Shifting by 1 unit to the left, right? So it'll be kind of like this. So at 1, it was 1. At 2, it was 4. With the 4 value, will not shift to the value at 1. So 1, 2, 3, 4. 1, 2, 3, 4. Right. So if you move from 0 to 1 position, you get 1. So let's do like this. 1, 1. And then at 2, we have, at 4, we have 2, right? So not there. Square root of 4 is 2. So instead, 4 places from here, 1, 2, 3, 4, we get the value of 2. So that is the graph of the function square root of x plus 1, right? So at this moment, this value will be 2 for 3 as the x value, correct? Since it has moved 1 unit to the left. So we can sketch both the graphs on the graph paper, and now it is a good idea to sketch the graph of h of x. So let's sketch the graph of h of x. Okay. So as far as the portion of the graph is concerned, which is beyond this point, we have to make a hole here and continue with the same graph. So the graph between minus 1 and plus 1 will now get reflected on the x-axis. So this intercept will come right there, and the value here is approximately this place. So we could actually sketch it like this. Correct? So that becomes the graph of the function given to us, h of x. This becomes very critical to figure out what this particular value is. Now, definitely, if I substitute 1 here, then we get a value of, let's say, right, h of 1, because that is part of our range. So we have to find this value. So we'll find h of 1 now. By substituting, we get the f of x value as minus 1 times square root of 1 plus 1, which is square root of 2 with a negative sign. So we have this value at square root of 2, negative. And now with the given graph, we can easily write down the domain and the range of the function. So let's write down the domain of the function, which is x belongs to real numbers, where x is greater than the value of -1 and x is not equal to 1. As far as the range is concerned, for the given function we're talking about at moment h of x, the range is that y value belongs to the real numbers, but the y value is between minus square root 2 and 0, where 0 is included, union y greater than, so that value is square root 2. Correct? So that is how you're going to write down the range for the particular function. Correct? You could have given the range in interval notation also. So let me write down range in the interval notation. Also domain you could have given in interval notation. So in that particular case, the notation if I change, then we could have written this as -2 is not included. So this bracket -2, 0 is included, union. Here square root 2 is not included. So square root of 2 to infinite. So that is how you could have written range alternately. Okay. Now let's take up the last question, which has not been copied here correctly. So let me rewrite the question here. So it is 4 minus x squared, right? So m of x, we are going to discuss f of x times 4 minus x squared. So let's write down the question once again. We need to sketch the graph of m of x, which is f of x times square root of 4 minus x squared. Now once again, we know what is f of x. F of x is given to us as equal to 1 or minus 1. If x is greater than 1, it is 1. But if x is less than 1, it is minus 1. Sketching it on the graph paper will look something like this. For f of x, we have a hole at 1 moves right, hole at 1 moves left. So that is f of x. Now how do you sketch the graph of 4 minus x squared? Okay, 4 minus x squared is a semicircle. So with zeros are plus and minus 2. So that is 4 minus x squared. If x is 0, you get square root of 4, which is 2. So the graph will be kind of like this. So remember, square root of 4 minus x squared is a semicircle. Right? Radius 2. As shown in the graph. Correct? Now, let us sketch the graph of m of x, which is product of f of x and square root of 4 minus x squared. So we need to find the value at 1. That will be positive on one side and negative on the other side. So if I write 1 for x, then what is m of 1? M of 1 will be square root of 4 minus 1, which is square root of 3. So this value here is square root of 3. So this value here could be written as 1 square root of 3. Correct? As far as the graph on the right side is concerned, right side of 1, it is going to remain exactly same. Correct? With a hole at 1 square root 3. On the other side, it is going to get reflected. So this point, which was at 2, will now be at minus 2. And the point of square root 3 will now be minus square root 3. And the 1 at 0 will definitely be 0. So the graph now will be kind of like this. Is that clear to you? The semicircle with maximum at minus 2. Correct? So that gives you the graph of the function m of x. Clear? So let's write down the domain for the function m of x. So in this case, the domain is what? The domain is within x equals to plus minus 2, within that interval, where 1 is not in the domain. So you could write domain as from minus 2 to 1, right? Where 1 is not included, union from 1 to plus 2. So that becomes the domain of the function. As far as the range is concerned, the range of the function will be what? The maximum value, which is seen in the graph, is square root of 3. And the minimum value is minus 2. Therefore, the range will be minus 2 is included. However, square root of 3 is not included. So you have to be careful in mentioning this particular range. So don't include square root of 3 since there is a hole at x equals to 1 for f of x, and that really affects the graph. So that becomes the domain and range of the given function. So I hope with this, the concept of composite functions, especially working with absolute function, is very clear, right? So the idea here is that whenever you're working with composite function, the domain is combination or the intersection of the two given functions. So a short note could be something like this. So domain is intersection of functions. So only points which are common in the domain of both the functions will be considered for the domain of composite function, right? As we have seen in this particular case. And we are also seeing that the effect of this function f of x equals to square root equals to absolute value of x minus 1 was kind of a step function, right? So in most of the graphs, we had this particular step with the hole on 1 going left, hole at 1 minus value. So that dictated our domain. That domain cannot include the value of x equals to 1. For rest of the functions which were multiplied by this, 1/2 remained unchanged and the other half was reflected. So this particular portion, so there are two portions which we are working with most of the time. So the effect of the portion which was x less than 1 was reflection on x-axis. The other, where x was greater than 1, no change. Since effectively we are multiplying just by 1, which doesn't make any change. In the other case, it was minus 1, so it was reflecting it on the x-axis. It changed both domain and range. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.